Hello students, today's class we'll see study of gas laws, that is part 4, that is numericals based on gas equation. We'll see the first problem at 0 degrees Celsius and 760 mercury pressure. So your temperature T1 value is going to be Celsius, you're going to convert it into Kelvin. 273 plus 273 will be getting 273 Kelvin, and the pressure value is 760 mercury. Now the gas occupies a volume of 100 centimeter cube. The Kelvin temperature, absolute temperature of the gas is increased by 1 by 5th. So your temperature has been increased by 1 by 5th means, so the original temperature is 273 into 1 by 5 plus 273. So what we are going to do is, since you have 273, I am going to take common as the thing 273. You are going to multiply plus 270. The original temperature you have to add. That's what is. This is the original temperature has increased by 1 by 5. So you have to write original temperature as well as 273 divided by 5. So I am going to take common as 273, that is 1 by 5 plus 1. So when you take LCM here, you will be getting 1 plus 5, that is 6 by 5 you are getting now. So this is your final temperature. Now coming to the initial, that is the final pressure, while the pressure is increased by 1.5 times. So the pressure value, it is 1.5 times means you are going to make it as an improper fraction. 2 into 1, 2, 2 plus 1, 3, 3 by 2. So the initial pressure is 76, which you have taken here. So the temperature also we have done the changes, and this also we have done the changes, that is pressure value into 3 by 2. Your original pressure multiplied by 3 by 2. So cancel it, you will be getting 1140 mercury. Now let's see about that is 273 into 1 by 5 plus 273. That's what we have done. The final value which you are getting here is 273 into 6 by 5. Now we'll see, we are supposed to calculate the V2 value. So you know that P1 V1 T1 P2 T2 V2. So you know the gas equation is this one, P1 V1 divided by T1 equal to P2 V2 by T2. So we are supposed to calculate V2, right? V2. So cross this thing, you will be getting P1 V1 T2 divided by P2 V, that is T1 into T1, because V2 only you are going to calculate. That will come in the denominator. Now substitute all the values whatever we have taken. That is P1 value is 760 and your V1 is 100. So 760 into 100 into what is your T2 value which we have calculated and kept. Your T2 value is 273 into 6 by 5. So 273 into 6 divided by 5. Now what is your P2 value here? P2 value which we have taken here is 1140. So write 1140 into what is the next value which we have to write it? T1. So your T1 value is 273. So substitute 273 here. So what is the value which you are going to get is, cancel this one and cancel this 0. You have to see this 5 goes 20 you will be getting. Are you able to follow? 20 you will be getting here. And now this 6 we can cancel it either in 3 tables or whatever changes you can do it there. If you multiply this with what is it? 4 times. 4 times it will go more. So just we will cancel it in the 3 tables. 3 2s are 6 and here 3 3s are 9. Remainder 2 8. So 38, this goes 2 twice, right? 2 8s are 16. Remainder 1 out. So you'll be getting it as 2 into 20 is 40, 40 into 2 is 80. So 80 centimeter cube, because your volume value is 80 centimeter cube. This is the value you are going to get it. So this is your final volume. So because volume we have expressed in centimeter cube. So if in case they have not given the other pressure and the volume, they given in the terms like this, so you are going to make it as a improper fraction and do the calculation. So you have to add it to the original temperature or original pressure, and this you have to multiply. Since it is increased by means you have to multiply it. That's what they have done. This is something a different problem. Let's see the second problem. See here, a fixed mass of gas has a volume of 750 cc at 23 degrees Celsius. So 750 cc means your V1 value is going to be 750 cc. And the T1 value which they have taken here is minus 23 degrees Celsius. So T1 value minus 23 plus 273, when you add it, you will be getting excuse me, 250 Kelvin here. And as a volume of this one, and they have given the pressure as 800 mm pressure. So the pressure value is 800 mm mercury, and calculate the pressure for which its volume will be 720 cc, the temperature being minus 3 degrees Celsius. So your V2 value is going to be 720 and T2 value is minus 3 degrees Celsius plus 273, you will be getting 270 Kelvin. Now making use of this gas equation, that is P1 V1 by T1 equal to P2 V2 by T2. So see, I have to calculate the P2 value, so keep it as P2, P1 V1 into T2 divided by, keep that P2 here and V2 into T1. This T1 will go this side and P2 will come. So now what we are going to do, you have to go substitute. Your P1 value is 800. It is 800. So write it as 800. Now your V1 value is 750. So write it as 750 into your T2 value is 270 into 270. Then divided by, what is your V2 value? 720. So write it as 720. And T1 value is given as 250. So substitute here as 250. That is 250. So now what happens here? Now cancel the 0 and 0. This 25 will go thrice, and this 0 will cancel it. And if you take this one, say for example 27 in 3 tables, if you cancel, 3 9s are 27, 3 2s are 6, remainder 1 3 4s are. So now this 3 will go here 8 times and this 8 will go 100 times here, and finally I am getting the value as 900. So this is the pressure which you have calculated. The pressure value is expressed in millimeter mercury. So that is your pressure value, mm mercury. So this is the answer for this problem. Now let's see about the third problem. We'll read the problem. A fixed volume of a gas occupies 2280 meter cube. Now at 27 degrees Celsius and 70 centimeter of mercury. So your P1 value is going to be 70 centimeter of mercury. What is its volume at STP? STP means always the standard temperature and pressure we use. Temperature we are going to use 273 Kelvin, and the pressure value which you are going to use it, if it is given centimeter, I have to use 76 centimeter mercury. Or if it is a millimeter mercury means I have to use 760 centimeter cube. 760 millimeter cube. Always, excuse me, the standard temperature and pressure means you have to substitute. They will not give the temperature and the pressure value of the final thing. They will be giving the standard temperature. So you have to make use of this temperature. Don't think that they have not given the data, that you have to write it. 273 Kelvin and the pressure value is 76 centimeter mercury. And if it is centimeter, the other pressure value, you have to give this value. If it is millimeter means you have to make use of the 760 millimeter mercury. Now we'll see that thing, what calculation. See, V1 value which is given here is 2280. I think it is given as 2280 value. The value which is given here for pressure is 228 meter cube. So that is the value which you are going to substitute here, 228 meter cube. So this is the value which you are going to make use of the thing. So now what we are going to do is, it is centimeter actually, this is not 0, centimeter. So the other problem here also what we have done, this is centimeter cube, not 0. This is centimeter cube they have given. And now coming to this problem, that is temperature is 27 degrees Celsius they have given, initial temperature, plus when you add 273 you will be getting 300 Kelvin. Your P2 value is good. Since the other pressure is measured in centimeter, you have to give the data in 76 centimeter mercury, and T2 value is standard temperature. This is the standard temperature and the pressure which you are going to substitute here, 273 Kelvin, and V2 value you are going to calculate. So make use of this gas equation, P1 V1 by T1 equal to P2 V2 by T2. So your V2 value is equal to, see, P1 V1 into T2 divided by P2 into T1. So what is your P1 value? The P1 value which has been represented is 70. It is 70 here, and your V1 value is actually, it's given as 228. 228, that is the value. And coming to the T2 value, temperature is 273 divided by, and your P2 value is going to be 76 into the value which you are going to get it here is T1 is 300. So now cancel the 0 and 0, and now in 3 tables 10 it goes, and this one 91 in 3 tables. Now this you can make use of the 2 tables, 2 5s are 10 and 2 3.5 I'm getting. So now you can make use of this one in the 2 tables, 238, and now this goes 114, and again you can make use of this 2 tables, 2 5s are 2 7s are 14, and this one 19 times. So 19 into this one 3, you will be getting 57. So 3 here. Now you will be getting the answer as say for example this 5, it will go 0.7. So 0.7 into 3 you will be getting it as 2.1. When you multiply with 91, you can just multiply and tell me. It is 1 2 9 1s are 9 2s are 18. Now you will be getting the answer as 111, remainder 1 9 1. So 1 decimal place is 1. So your answer is going to be, your volume value is 119.1 centimeter cube. This is your answer. Now coming to the fourth problem, calculate the volume of a gas X at STP if it occupies 380 liters at 300 Kelvin and 70 centimeter of mercury. A gas at STP. So STP means, see here, your volume which is given here is in liters. This is not in centimeter, liters they have given. So 380 liters you are taking, and temperature value is given as Kelvin only. It is not given in Celsius. Now your pressure value is 70 centimeter. Since it is 70 centimeter, your P2 value is also going to be 76 centimeter mercury. And standard temperature, you all know, make use of 273. So we are going to calculate volume. Calculate the volume only they have given. Now P1 V1 by T1 equal to P2 V2 by T2. This is your gas equation formula. Now you have to calculate the V2. So cross multiply P1 V1 into T2 divided by P2 into T1. Now